Today we're going to look at some word problems that have to deal with money situations out in the real world and how money is calculated for payments and for interest and things like that. So we're going to start off with some interest questions and formulas that we're going to be using. Back in grade school, you probably dealt with a thing called simple interest. This is the formula you use that the interest that you earn or get is equal to the principal times the rate times the time. The principal is the dollar amount that you start with. The rate, usually given as a percentage, but you need to change to a decimal. And then the time is usually in years. Next, we look at compound interest. Compound interest has this formula. And they can change the lettering. The lettering doesn't matter too much. I'm going to try and keep it to where your textbook has it. They have a K here, KT. And then, again, P, that is your principal. And then you have R is your interest rate, used as a decimal. Then you have K, which is the number of times the interest is compounded per year. And compound just means the number of times that they actually calculate the interest in a year. And then T is time in years. So these are what the standard letters represent when you do this. A is the amount that you have in an account after you do this. This example up here, you just find out what the interest is. This one, A, is the amount in your account after. Okay, it's not the interest; it's the amount that's in the account after you have the original principal amount plus the interest combined. Then you have another one that they use, which is called continuously. Compounded interest. And continuously compounded interest means that they're constantly calculating the interest every fraction of a second, like constantly. And this formula then turns into this formula. P times E to the R T, PERT. P still is the principal, R is the rate as a decimal, T is still time, and E is the natural base E. We're going to be using these two problems right here in doing some calculations. Let's do one right now. In this example right here, we're going to use the compound interest formula. This is the one that you're going to need to memorize, the compound interest formula and the continuously compound interest formula. I want you to memorize those. So in this particular example, I'm going to give you the principal is going to be $1,500. The rate is at 7%. T is 5 years. And K is 4. And this usually means quarterly. So most investments are use quarterly compounding, so 4 times a year. And so all you have to do really is to find the amount after. It's just plug these numbers in here in the appropriate fashion. So the amount that I will have after investing $1,500 into an account that pays 7%, compounded quarterly for 5 years, would be this: 1,500, 1 plus, this is a decimal, 0.07 divided by the 4, and then 4 times 5. And then this is just a calculator exercise. You can just type it in as you see it. see, start a new doc. Just trying to get that glare out of there. And you just type it as you see it. So 1500 times, open the parentheses, 1 plus 0.07 divided by 4. Close the parentheses, raise it up to, and I'm just going to go 4 times 5, which is 20. And then I get an answer here that I will have 2,122.17. Remember, this is a dollar amount, so you want to round to 2 decimal places. All money amounts should be rounded to 2 decimal places for the nearest penny. And so that's how much will be in the account at the end of 5 years. Another thing we want to talk about is we're getting to more advanced concepts. Is what is this thing called an annual percentage yield? When you start going out in the real world and start looking at loans and comparing things, you're going to see this terminology. They abbreviated as APY, annual percentage yield. And this number is used to compare investments, the percentage rate that, when compounded annually, means one time a year, will yield the same return, meaning the same amount, as the given interest rate. With the given compounding period. So this example right here, we have a annual percentage rate. So this would be kind of like the APR, annual percentage rate of 7%. We're going to do this for 5 years, but we're going to compound it 4 times a year. So what they're saying here is the annual percentage yield is, what would the rate be that will give me the exact same amount of money in the account, but only compounded 1 time a year. So that's how they kind of compare different investment accounts. Because some people may give you a 7%, some people may give you a 7.1%, but then they change the terms and different things, and then you got to try and figure out which one is best. So to calculate this, you're basically doing a modified version. See this right here, where K is going to be 1. So it just boils down to this right here. And it should look familiar to you. It looks just like that, the growth formula that we talked about previously. Another name we need to know, annuities. And we're going to look at future value. So, an annuity. An annuity is a sequence of equal periodic payments. What's an example of an annuity? Your investment accounts. If you win the lottery and you don't choose the cash value, you choose the payment plan, that's an annuity. And so that's how they pay for all this kind of stuff. Future value. The future value is the total value of the investment returned from an annuity consists of all periodic payments together with all of the interest. So usually remaining, the amount that's remaining. So if I have a 30-year annuity, the future value at the beginning is one value. And if I take the annuity for 10 years and then I ask what's the future value of that, well, there's only 20 years left on this annuity. So that would be the future value is be what's the remaining periodic payments plus the interest for the next 20 years. That's a future value thing. All right, and this one has a formula. This formula you do not need to memorize for a test. I will give it to you. Then this is equal to R, and we'll talk about what all that is here in a minute. And you will have 1 plus I, and I'll describe what that is too. All these letters, I'll tell you what they are. So we have that formula right there. So what is N? It's the number of equal payments. How many there are. R is the payment amount. And then I is the interest rate per period. So what does that mean? Well, if I have, let's go back to that compound interest one, you'll kind of see what I'm talking about. This value, R divided by K, is what they're referring to as the interest rate per period. So we had a 7% annual interest rate. We divided it by 4. So then that value right there is what the interest rate would be per period. That's what they're referring to when they talk about I down here. Now, this is usually used for like retirement investments and when you're putting money into things. And you can also get it as putting money in. There's one more I want to look at over here, and this is the annuities. Again, with annuities. And we have what's called present value. This is the net amount of money put into an annuity. That's what the present value is. This one is used mainly for loans, which are mortgages, things like that. This is kind of how this is how this one's used. And so the present value and the formula will look very similar. And all these letters mean this basically the same thing. So N is the number of equal payments. And R is the amount of the payment. And I is the interest rate per period. So this formula is used to calculate usually that. So if you borrow money from a bank, they're going to tell you how much you owe them each month. This is the formula that they use to determine what your payment is. That's what R is. They'll say, I'm going to give you a loan for, let's say you want to buy a car. Say it's $30,000 loan for a car payment. You're going to pay me 6% interest. And then they will use this formula to calculate what your monthly payment will be. That's what this one is for. So with these formulas, and this is another formula you do not need to memorize, I would give this to you on a test. We can then go and look at some of the problems that we have that use these formulas. So this example, I'll be looking in your textbook on page 305, 304, 305. And I want to look at question number 15. And question number 15, they give you some information here. They're asking you to find the future value. They tell you that R is $450, and then R is 5.25%. They tell you T is 10 and K is 12. And they're asking for find the future value accumulated in an annuity after investing periodic payments of $450 for T years, with the payment and interest calculated this many times per year. So this is 12, so we're talking monthly. So what they're saying here is you're going to put $450 into this account every month. So how much money would I have in this account after that time? And so that is a future value formula. So the future value is going to be R, 450, times, and then you're going to have up here in the fraction, you're going to have 1 plus I, and I is that percent number as a decimal divided by 12. So I is 0.0525 divided by 12. 0.0525 divided by 12. And that's raised to the n, and n is the number, I have an n, the number of equal payments. So what is that? The n is really that product right there. So n is going to be 120, 10 times 12. And then this number right here is the same amount. And then this up here was a minus 1, I forgot. So we need to type that in to our calculator. And again, I would just type it in as I see it, just being careful with the fractions and all that kind of stuff. So I have 450 times parenthesis fraction. And then here I'm going to have a parenthesis on top, and I'll have 1 plus 0.0525 divided by 12 raised to the 120 minus 1. And then down here, 0.0525 divided by 12. Control Enter. And I get a future value of $70,819.63. So that's kind of how these things work. Here's another example. I'm going to do number 21. This is the last example for the video. So number 21. This one asks us a little bit different question. It says, if John invests $2,300 in a savings account, so $2,300 in a savings account that pays 9% interest, compounded quarterly. So in this case, K would be 4 quarterly. How long would it take John's account to have a balance of $4,150? So in other words, I want A to equal $4,150. So this is using the compound interest concept. Here's the formula again. R over N times T. And I've given you P. I've given you A. A. I've given you K, and I've given you R. So what are we looking for? We're looking for the time, because we want to know how long. So as we plug these numbers in, 2,300, 1 plus 0.09 divided by 4, and then up here, let's see if it said the time. I forgot the time. Oh, we want 5 times. And this would be 4 times t. So how do I solve this? Well, I got to get to that exponent up there. So I'm going to be using this is an exponential that I have to then use and change forms into a log. Start by dividing by the 2300. And I'll reduce it later if I need to. And then in here, you can actually take that and give it into a single number. So what is 1 plus 0.09 divided by 4? And use the whole entire decimal. Don't chop it off to the 4t. So once I have that form right there, then I can see that I have an isolated exponential so that I can change the form. So I get the log base this of 415, 230 equals 4 times t. And then I can multiply both sides by 1/4. And my time then would be equal to 1/4 times the log of 1.0225 of 415 over 230. And then we would type that in and get an approximate time value. Times the log and 1.0225. You got to type it all in there. 415 divided by 230. 6.631 years. Rounded to 3 decimal places. So these are some of the problem types we're going to be doing, and we'll do more examples in person.